Hi friends, I'm back again with one more video, and in this video we are going to discuss time and work. This is one of the good topic from quantitative aptitude. If you are preparing for any competitive exams or placement exams, questions from time and work are expected for sure. But it is always intimidating for you to see the problems and to see the complexity of the problems. A little bit worries you how to solve these problems fastly or as soon as possible, how to get the answers. This is what the issue you may get here. And it's always intimidating for you to see the problems, like let's say a work can be done by you in 4 hours, whereas the other person can your friend can do it in 3 hours. So what if you both work together? In how much time it will be completed? Correct. This is how the problems are there. And in this there is a basic method you can use and solve each and every problem, but quite calculations are involved in this. So instead of that, if you target on the things like LCM method, where you can use this method in 75% of the problems from time and work and get the answers as soon as possible. So here the name itself, you can understand we are going to deal with the things time, work, and work rate. Work rate is nothing but the efficiency. Efficiency. So the basic formula we have in this topic is efficiency multiplied by time will give you the work done. So this is what the entire time and work topic deals with. Okay, let's see. And after this video, I'm pretty confident that you will be well versed with the knowledge enough to solve any problem from time and work, from basic to high level problems. If you once complete this video, and if you have any doubts, you can come back and watch this video once again. And time and work topic is not that simple topic where I can explain it in one video. Okay, I'm going to do it in parts. Let's see the first part of this topic. This is the first question, guys. Yeah, the first question says A can do a piece of work in 10 days, B in 15 days. Find how much time they will take to complete the work if they work together. So, what it was given, there is a person A who can complete a work in 10 days, and there is another person who can do the same work in 15 days. So, what if they both work together? In how much time they are going to complete the work? That's the question. So, here you can solve this question in this way, the basic method. I'm going to solve this question in basic method, guys. The basic method is this. Let's say if you are able to complete a work in 10 days, and what part of work is done in 1 day, right? Let's imagine if you can complete an assignment in 2 days. Let's say you are a good student, you will quantize your work equally on given number of days. So in 2 days you are able to complete one assignment. So in 1 day, how much assignment you will complete? Half, na? This 1 by 2. Let's say if you are able to complete an assignment in 4 days. So in 1 day, how much work you will do? So 1 out of 4, correct? 1 by 4 work is done. So similarly, if you are able to complete a work in 10 days, what part of work is done in 1 day? That is nothing but 1 day's work. It will be 1 out of 10, 1 by 10. Similarly, B can do it in 15 days. So in 1 day, how much part is done? 1 by 15. They both work together, now. A does A is capable of doing 1/10 of the work in 1 day, and B is capable of doing 1/15 of work in 1 day. So add them, you are going to get the combined efficiency. So what is 10 and 15 calcium? It's 30, and 30 goes in 10 for 3 times, and in 15 2 times. So it is 5 by 30. 5 by 30 is 1 by 6. That means per day you are able to do 1/6 of the work. So how much part of how many days it will take for you to complete the total work? So this is what I'm going to do. If you 1 day work is nothing but the efficiency. Okay, so just now I told efficiency multiplied by time is nothing but work. So per day 1/6 of the work you will do for X days you are working, and the work is completed, 100% of the work completed. So equate with it, equate with 1. So then X equals to 6 days. This is your first answer, first question answer. Okay, So in this, I have not explained you LCM method. Next problem, I'll explain you that method. Okay, let's move on to next. Fine. So the next problem is this similar problem. Uh, Take time and read the question. Okay. A can do a piece of work in 10 days and B in 12 days. Find how much time they will take to complete the work if they work together. Correct. Similar problem. Let's say, okay, it was given A completes a work in 10 days, B in 12 days. Now, if you observe here, I'm using a formula called efficiency into time is equals to work. Now if you observe my shortcut method here the individual time takens were given. It was not given anything about work, what work they are doing, or anything about their efficiency. And moreover, try to understand, I cannot estimate anybody's capacity. Efficiency I cannot estimate, but I can assume the work. Okay, so what I'm going to do is, how I'm going to assume the work is, so I'll assume the work as LCM of 10 and 12. Why I'm taking 10 and 12 is, the reason is this, guys. See, they're, let us assume that they are making, okay. Look at here, guys. LCM of 10 and 12. You need to take LCM of 10 and 12 and assume it as work. Okay. So, what is LCM of 10 and 12? It is 60. So, consider 60 units of work. Or else, assume like they are making the tables for a classroom. Only they are making 60 tables. So now calculate the efficiency of A. Just try to understand. A can A can make 60 tables in 10 days. So per day, how many tables he will do? He'll make. I'm going to use this only. Efficiency is nothing but per day work. Time was 10 days, and he's able to complete 60 tables. So per day, how many tables he'll do? He'll make 60 by 10, which is 6 tables per day. I can say like this. That is his efficiency. So A's efficiency is 6 tables per day. And what about B's efficiency? Use the same thing again. It would be B is able to make 60 tables in 12 days. Now, so per day, how many tables he'll do? 60 by 12, which is 5 tables per day. Now, just look at here. They both are working together, right? In one day, A is capable of making 6 tables, and whereas B is capable of making 5 tables. So both combined, how many tables per day is completed? 11 tables per day. Now we need to calculate combined time. If they both are working together, how many days it will take to complete the work? Again, I'm going to use the same formula. Efficiency into time equals to work. The work to be completed is 60 tables because they're doing the same work, 60, and time you need to calculate. You know the combined efficiency. Combined efficiency is how much? 11. So time equals to 60 out of 11. 11 5s are 55 and 5 is remaining. 5 by 11 days. That's how you can answer the question. This is the answer for second problem. So this is the LCM method, guys. Try to follow. We are going to use this method again and again in other problems also. I hope you understand this. If you don't understand this method, rewatch it again, this method, and then continue with the video. Let us move on to next problem. Fine. Now look at this problem, guys. A can do a piece of work in 20 days and B in 12 days. Both started the work, but B left the work after 6 days. Find the time taken by A to complete the remaining work. Now, if you observe, this problem is not similar to the previous problem. Here, previous problem, both the people are working from starting to the ending. That time we have calculated. But here, there is some in and out case. Like both started the work, but B left after some days. So after some days means for these some days, both people is able to complete a part of work, and then some part of work is remaining. Now that part of work is done by the other person who is working, correct, and the work is completed. That's what the question here. Let us start with same basic. A is able to do a work in 20 days, B 12 days. We'll assume work work. How we'll assume work? We'll take LCM of 20 and 12. So what is LCM of 20 and 12, guys? It is again 60 units. So if you want, consider it as tables or units, whatever it is. Now you calculate efficiency. What is efficiency of A? 60 by 20, which is 3 units per day. What about B's efficiency? 60 by 12, 5 units per day. Okay. Now look at the problem, guys. Continue with the problem. Both started the work. So now what you do is either you can solve problem without using pen and paper here, or else you can make a basic equation according to the condition given there. Both started the work, but B left the work after 6 days. That means A and B started the work, B left after 6 days. Now that means till 6 days they both are working. So both working for 6 days, efficiency of A and B multiplied by time will give you the work done in this 6 days. So a part of work is done. And what happened is the total work is not completed. B left. Now who is working? A alone working. He worked for some number of days, some X days, and the work is completed. So in the LCM method, work we have assumed it as 60. So equate with 60. So what is combined efficiency of A and B? 3 plus 5, 8. Okay, I'm going to write like that. Multiplied by 6. And what is A's efficiency? 3 units per day equals to 60. So 3 plus 5 is 8. 8 times 6 is 48. 48 plus 3x equals to 60. 3x would be 60 minus 48, which is 12. So x would be 12 out of 3, which is 4 days. This is your answer. Clear? So try to understand how to make this basic equation. It will help you to get the answer. Okay guys, let's move on to next question. Yeah, basically this is also the model from the previous question only. It is similar model like previous one. I had put it intentionally for your practice. You had come across a model there. Now I want you to practice this. Pause the video, try to solve the problem, and then check the problem. And now in this problem, I'm not going to write each and every step like this, like work, LCM, efficiency. I'm not going to write all these things in a simple way how you can do in my exams. I'll do that. Okay. So and I'll revise you one thing, guys. In LCM method, what we are doing? LCM method, what we are doing? We are doing initially we are assuming the work. How we are assuming the work? We are taking LCM of the times, given times. And next what we are doing? We are calculating efficiency. So calculate efficiency. This is the process which you remember. Okay. How we are calculating efficiency? We are using efficiency multiplied by time equals to work, whereas efficiency equals to work by individual time. And then third, what we are doing? We are following the conditions given in the problem. Whatever the conditions has given, we are following. This is what we are doing. Okay. So now look at here, guys. A can complete a work in 40 days, B in 30 days. So A 40, B 30. Then what is the LCM of 40 and 30? That is work, which is 120 units. Now calculate efficiency. Efficiency of A would be 120 up by 4, which is 3 units per day. And what is efficiency of B? 120 by 30, which is 4 units per day. Now what happens? Both started the work, but A left the work after 7 days. So make a basic equation. A and B both started the work, and A left the work after 7 days, means they both are working for 7 days. A part of work is done. Now A left. Who is working? B is working. For some X days, the work is completed. So the work would be equal to 120 units. So A and B both combined, how much work they'll do? 7. 7 sevens plus B alone 4. So 120. So 7 sevens are 49. So 120 minus 49. How much, guys? 120 minus 40 is 80. And 80 minus 9 is 71. 4x would be 71. So then x would be 71 by 4. So what is 71 by 4, guys? It is 17.75 days. Okay, I hope you understand. Or else mixed fraction, you may get 17 by 4 days. Clear? This is the answer for your particular question. Okay, let's move on to next problem, guys. Yeah, this is also similar to it is a little bit not similar to previous problem, a little bit different condition. Okay, so A can do a piece of work in 10 days, B 12 days, and what is given there? With the help of C, they both completed the work in 4 days. Find the time taken by C alone to complete the same work. So with the help of C, they both completed. That means all three people worked. A, B and C, all three worked and they are able to complete the work in 4 days. Now what you do is, you take whatever, whenever you see the numbers like this, blindly follow LCM method. So you assume work. How will you assume work? You will take LCM of 10, 12 and 4. LCM of 10 and 12, 10, 12 and 4 will be 60 units. Okay, I'm not going to write again and again. You would have well versed with what are the steps you will follow in LCM method, I hope. Okay, now next what you do is you calculate efficiency. 60 by 10, 6 units per day, and B's efficiency 60 by 12, 5 units per day, and A, B and C combined efficiency 60 by 4, 15 units per day. Now try to look at here, guys. A alone 6 units, B alone 5 units, A, B and C, 3 people combined 15 units. Then what is C's efficiency? A plus B minus A minus B, which is 15 minus 5 minus 6. It would be 4 units per day. That is C's efficiency. If C is able to complete 4 units in a day, and how much time it will take for him to complete 60 units? I'm going to use my formula again, same, efficiency into time equals to work. Work to be done is 60, efficiency of C is 4, and time taken you need to calculate. 60 by 4, it is 15 days. This is the answer for this particular model. I hope you understand this. Let's move on to next. Now the next problem is this. See guys, it's a little bit similar, but some extra things were there here. Look at here. A and B can do a piece of work in 10 days, B and C in 12 days, C and A in 15 days. Find how much time will A alone takes to complete the work. Now, in this particular problem, a pair of persons working time was given. Okay, now he is asking you to calculate the individual time of A. We follow same LCM method whenever you see numbers like this. A and B, how many days? 10 days. B and C, 12 days. C and A, 15 days. What you do? You take work. Work is 10, 12, 15 ka LCM, which is 60 units. You calculate efficiency. Efficiency of A and B, 60 by 10 is 6 units per day. And efficiency of B, efficiency of B and C, 60 by 12, which is 5 units per day. Efficiency of C and A would be 60 by 15, 4 units per day. You got this? Now what you do is, try to understand A and B combined 6 units, B and C combined 5 units, C and A combined 4 units. What if I add all of this? You'll get A for 2 times, B 2 times, C 2 times. Now, then can I say 2 times A, B and C efficiency is nothing but 6 plus 5 plus 4, which is 15 units per day. Twice the efficiency is 15 units. Then what is the actual efficiency? Which is 15 by 2, 7.5 units per day. Now, what you need to do? Time taken by A alone, you need to get. Now, what I have is A, B and C combined efficiency I have, and B and C combined efficiency I have. If I subtract B and C's efficiency from all 3 persons, A, B and C's efficiency, then I'm going to get A's efficiency. When I get A's efficiency and when I know work, I can calculate the time now. That's what. So here subtract this 7.5. A's efficiency would be 7.5 units minus 5 units. So it is how much, guys? 7.5 minus 5, it is 2.5 units per day. So A is capable of doing 2.5 units in a day. So efficiency into time equals to work. Efficiency is 2.5 time. You need to calculate, and the completed is 60. So how much, guys? How much time? It is 24 days. And actually here you no need to calculate all these things also. Simple idea. A, B and C difference is sorry, 7.5 minus 5 is 2.5, and you know 5 units per day, 12 days they are taking. So now what happened? 2.5 units, which means efficiency became half, then obviously time will become double. By using that idea also I can answer 24 days. Okay, this is the answer. I hope you understand this. Let us move on to next. Yes, guys, now see the complexity of the problems will rise in this problem. Look at here, guys. A can do a piece of work in 10 days, B in 12 days. Find how much time they will take to complete the work if they work alternatively starting with A. What is meant by alternatively? It is nothing but working day after day or day by day and starting with A. That means first day A will work, second day B, third day A, fourth day B. Alternatively they are going to work and they are going to complete the work. Now in how many days the work will be completed? That is the question. Now let's say again I start with LCM method only. A 10 days, B 12 days. Now take a work is 60 units, LCM of 10 and 12. Now calculate efficiency. 60 by 10, 6 units per day, and B's efficiency 60 by 12, 5 units per day. Now look at here how the work is completed. Total work to be completed is 60 units. First day A will work, A will do 6 units. Second day B will work, B will do 5 units. Third day A will work, again 6 units. Fourth day B, 5 units. Like that the work is going to be proceed. What happens? You just try to understand. This is one cycle. In one cycle, how much work is completed? 6 plus 5, 11 units of work is completed. And how many days? Both the persons are working in 2 different days. Now, first day A, second day B. So obviously 2 days. Correct. So one more cycle. 11 plus 11, 22. One more cycle. 33. One more cycle. 44. One more cycle. 55. So like that you got 6, 5, 6, 5, 6, 5. Total 5 cycles, and new cycle started. And try to understand, 5 per cycle 11 units, 5 cycles, 11 5s are 55 units is done. And how much work is left out of 60? 55 completed, 5 units remaining. So A will come and do 5 units only. So this is 2 days, each cycle 2 days, 2 days. So 5 cycles, 5 twos are 10 days work, 10 days time completed. Now A came and A is doing 5 units of work. Now what happens is A is capable of doing 6 units in a day now. So per day A, one day 6 units. So 1 unit, how much time? It is obviously 1 by 6 days. 2 units, 2 by 6. 3 units, 3 by 6. Similarly 5 units, it would have been 5 by 6 days. So the answer would be 2 times 5, 10 plus 5 by 6, which is 10 5 by 6 days. This is the answer. This is the answer. But if you want to use another way, what you do is, guys, I'll give you another division method here. Total work to be completed is 60 units. Take 60 and 60 units of work to be done. Each cycle 11 units of work is done. So divide with 11 units. So 11 5s are 55. So this 5 is nothing but cycles. So 55 units done out of 60. Then 5 units is remaining. who will come and work. New cycle starts with A, this. So 5 cycles now. Each cycle is 2 days. So 5 cycles would be 5 into 2, which is 10 days. You got 10 days still here. And then A is capable of doing 6 units per day. Now new cycle A starts and he'll complete only 5 units. So the time taken would be 5 by 6 days. So answer would be 10 plus 5 by 6, 10 5 by 6 days. That's how you can solve the problem, guys. So the second problem, the next problem which I had put is the same problem but starting with B. So in that problem, I'm not going to do solve like this. In a simple way, I'm going to do, it will not be very complexity like this. In this problem, if you understand, this is the first step and this is the second step and this would be the third step. So second step ka this. Okay, let us move on to next problem and try to solve the problem and then continue with the video. Now next. Achha, I had put in a different problem, guys. Okay, what you do is starting with B, you try to, okay, we'll solve that problem, guys. We'll solve that. We'll solve it. What we do is we'll solve the next problem, guys. We'll put 10 and 12 and starting with B. Okay. What we do is here it is mentioned A is capable of doing the work in 10 days, B 12 days, and the problem I'm writing in a short format, guys. Okay, so alternative work only, alternative work starting with B. What happens? Okay, so now look at here, guys. So the process I follow is the same. 10 and 12 LCM work, which is 60 units. And what is efficiency? 60 by 10 is 6 units per day and 60 by 12 is 5 units per day efficiency of B. Now what happens is B, A, B, A, like that the work is going to complete. Now look at here, guys. B is capable of doing 5 units, A is capable of doing 6 units. So 11 units completed and one cycle it is, and how many days? 2 days. What I will do, I'll take 60 divide with 11, 11 5s are 55 and the work remaining is 5 units. So this is 5 cycles. Each cycle how many days, guys? 2 days. So 5 cycles it would be 5 into 2, 2 days, which is 10 days. Now who comes and work? B will work. New cycle starts with B. New cycle starts with B. So what is B's efficiency? 5 units per day. B's efficiency is 5 units per day. And luckily 5 units are only left to do. So obviously B takes one more day. One whole day to complete 5 units. So the total time will be 10 plus 1, 11 days. So starting with A, it is 10 5 by 6 days. Whereas starting with B, it is of 11 days. So I hope you understand this. The next problem is alternative work only. I want you to pause the video and solve the problem for sure. Okay, let us move on to next. I'll try to solve this problem, guys. The process is same. A 8 days, B 18 days, work 8 and 18 ka LCM 72 units and efficiency 72 by 8, which is 9 units per day. And what is efficiency of B? 72 by 18, 4 units per day. And now starting with A alternatively. Okay, A, B, it is going to continue. I'll consider this as one cycle. A will eat A will do 9 units per day, B 4 units. So one cycle, 2 days, and how much work? 13 units of work is completed. Now total to be completed is 72. So take 72, divide with this cycle efficiency, which is 13. 13 5s are 65. Work remaining is 7 units. So this is 5 cycles. So I told you each cycle is 2 days. So 5 cycles would be 5 into 2 days, which is 10 days here. And then this 7 units, who will start new cycle? New cycle starts by A. What is A's capacity or efficiency? 9 units per day. So how much time it will take for him to do 7 units? 9 units per day. It is like per unit it would be 1 by 9 days. 2 units 2 by 9. 3 units 3 by 9. Similarly 7 units 7 by 9 days. So the total answer would be 10 plus 7 by 9, which is 10 7 by 9 days. Okay guys, now the next problem definitely I would have put starting with B. So you pause the video, try to solve it, and then see the solution. So the process will be same. Actually, if you observe till here, the process would be same, guys. I'll write in a simple way like this: A 8 days, B 18 days, work 72, and efficiency 9 units per day, and efficiency of B 4 units per day. Now B A, consider this as first day B, second day A, 4 units, 9 units, one cycle, 2 days, 13 units work is done, 13 units of work is done. So 72 divided with 13, 13 5s are 65, which is 7 units remaining. Now try to observe guys, this is 5 cycles, correct? Quotient is 5 cycles. Each cycle is 2 days. So 5 into 2, 10 days. It's okay. Now look at it. 7 units of work should be done. New cycle starts with B. B comes, B can do, B's efficiency is 4 units per day. Na? That means out of 7, B will eat 4 units and B will complete 4 units and he will take one complete day here. Now how much work remaining again? 3 units is remaining. Okay, 3 units remaining. Who will come to work? A will come to work. So 3 units. So A does 9 units in a day. So 1 unit it would be 1 by 9, 2 units 2 by 9. So similarly 3 units would be 3 by 9 days. 3 by 9 is nothing but 1 by 3 days. So initially 10 days, in this cycle 1 day and 1 by 3 day. So total 10 plus 1 plus 1 by 3, which is 11 1 by 3 days. I hope you understand this question guys. Okay, let us move on to next. Yeah, now look at here guys. A can do a piece of work in 24 days, B in 36 days. Both started the work, but A leaves after some days and the remaining work is completed by B in 16 days. Find after how many days did A left the work. If you observe third or fourth problem, there what happens is both started the work, but A left after 6 days or 7 days. That time was given, and find the time taken by B to complete the remaining work. That is the question in third problem. But here it mentioned after some days. Correct? We follow LCM method only. A 24 days, B 36 days. Take LCM as work. 24 36 LCM is 72 units. Now calculate efficiency. 72 by 24, which is 3 units per day, and B's efficiency 72 by 36, which is 2 units per day. Now try to understand, both started the work. So A and B both started the work, but A leaves after some days. We don't know after how many days. Consider it as X. This is a part of work is done here. Efficiency of both A and B multiplied by time, plus who is working? A left, B is working. B worked for how many days? 16 days to complete the remaining work. So the total work completed, which means 72 units. You can write the equation like this guys, or else without pen paper also you can try and solve it. Okay, let's see. B, A and B both combined, how much work they'll do? 3 plus 2 for X days, plus B alone 2 units per day into 16 equals to 72. So 3 plus 2 is 5x, plus 2 16s are 32, which is 72. So 5x would be 72 minus 32, which is 40. And then 40 out of 40 by 5 would be 8 days. That means A left the work after 8 days. That's how you can solve the problem, guys. It's not pretty hard problem. Without doing this equation also you can solve. How? You got efficiencies of A and B as 3 and 2, and it is clearly mentioned B completes the remaining work in 16 days. So total 72 units to be done. B does 2 units per day. So 16 days, how much work is completed? 16 times 2, 32 units. Out of 72, 32 is completed now in last 16 days. How much work is completed in the starting days is 72 minus 32, which is 40 units. And both combined 3 plus 2, 5 units per day. So 40 units to complete 40 units. How much time it will take? It would be per day 5. So total 40. So 40 by 5, which is 8 days. You can answer like this also. Let us move on to next problem, guys. Yeah, this is a practice for you guys. Okay, I am going to just write answer here. You just calculate, try to solve the problem, guys. So previous problem only, I just changed a few things here. Previous problem A leaves, in this problem B leaves, and the same process is same. This equation will be a little bit different. I'll write the answer, guys. Okay, so here B leaves after some days and the remaining work is completed by A in 12 days. Okay, the answer for this particular problem is, guys, 7.2 days. I want you to watch the previous problem again and solve this. Okay, I'm not going to solve it. Let us move on to next. Fine. Now look at here, guys. This is the other concept here. The problem says 10 men can bind 2400 books in 12 days, working 8 hours a day. How many men can bind 1800 books in 4 days, working 12 hours a day? We have one good formula here, guys. Work equivalence formula. Equivalence formula. What is work equivalence formula? It is M1 D1 H1 by W1 equals to M2 D2 H2 by W2. In this, what is D? D is days. What is H? H is hours. What is W? It is work. What is M? It is men, women, children, or anyone who is working. I call it as workforce. Use this, substitute, and get the answer. There are 8 parameters here. 7 parameters were given there, and the 8th one you need to calculate. So M1 is 10 men, and D1 is 12 days, and H1 is 8 hours. Work is 2400. And M2 you need to calculate how many men it is mentioned. D2 4 days, H2 12. Work completed should be completed is 1800. Correct? So now what you do is 12 ones, 12 ones, 12 12 cancelled, and 0 0 is gone. I can cancel this with 6 threes, 6 fours. Okay, now what you can do is 4 ones, 4 twos. So 10 into 2 into 3 by 4 is nothing but M2. So 2 ones, 2 twos, 2 ones, 2 fives. 5 threes are 15 men. So this is how you can solve this problem. I hope you understand. Let us move on to next. Next problem is 20 men can dig a well in 10 days. How many days it will take for 15 men to dig 2 such wells? If this if the time spent per day reduced by one third, guys, this is little bit important point here. First we'll see what is meant by reduced by one third. Okay, reduced by one third. Try to understand, guys. If earlier, if you are working 1 hour, If in earlier case, if you are working 1 hour, now you have reduced the time by one third, which means 1 by 3 reduced. So 1 minus 1 by 3, guys, which is 2 by 3 hours. So you are not working for one third. Okay, reduced by one third means 1 by 1 by 3. Reduced to one third means it is directly one third, 1 by 3. Okay, I'll apply the same formula, guys. M1 D1 H1 by W1 equals to M2 D2 H2 by W2. So M1 is 20 men, D1 10 days. Maybe hours is not given directly, but because of this word you got hours. Okay, so earlier 1 hour and work. Here same work he didn't said. He said two such wells in the second case. So what I do is consider one well is a work like X, and two such wells means 2x would be the work. And then he's asking you to calculate days. So 15 men was given, 15 days, and time spent per day is 2 by 3. Correct? That's how you can write the equation and solve. This is it, guys. This gone 2. If you bring it to here, 2 into 20 into 10 into 1 equals to 15 into ds into by 2 by 3. So 3 ones, 3 fives, 5 twos are 10, gone. So answer is D2 would be 2 into 20, 40 days. That's how you can solve this problem. It's a little bit good problem, guys. Try to solve similar problems from some other sources also. Okay, let us move on to next. Yes, this is very important problem according to me. Most of the times it was given in placement exams and even on other competitive exams also. Let us see. A contractor employs 200 men to complete the work in 12 days, but it was known that only 25% of the work is done in 4 days. How many additional men are required to complete the work on time? Imagine a situation, guys. Let's say you become a contractor, you got a government project, and you need to complete the project in 12 days. So what you thought is, you thought 200 men is capable of completing the work in 12 days. So you had employed 200 men, but after 4 days you had reviewed the work and you got to know only 25% of the work is completed. So in 4 days, if 25% is completed, obviously in 12 days you are not able to complete the 100% of the work. Correct? Because 25% 4 days, 25% is nothing but 1/4 of the work. 1/4 of the work is 4 days, so 100% of the work will be 4 in times 4, which is 16 days. But you don't have that much time now. You need to complete in 12 days. So that means at least after 4 days, what you need to do, you need to improve your manpower so that the work will be completed on time. Am I correct? So look at here. What you observed is 200 men are worked for 4 days and they are capable of completing 25% of the work. Now what happens is 75% of the work is remaining, and how many days is remaining with you? Out of 12 days, 4 days work is completed. So how many days remaining? 8 days. Obviously 200 men is not sufficient. He asked additional men. How many additional men in the question? That's why what I'm doing is 200 men plus X men. I have taken considered as a variable of the particular question which he asked. I didn't took X men directly, because when you get X you may think that will be the answer, but the question is additional men. So I'm going to apply my basic formula again. M1 D1 by H1, M1 D1 H1 by W1 equals to M2 D2 H2 by W2 in these two scenarios. M1 is 200 men working for 4 days. Hours were not mentioned in anywhere, so leave it. And the work completed is 25%. And M2, we need to it is given as 200 plus X. We have assumed it as 200 plus X. D2, which is How much work, how many days? 8 days remaining, and W2 would be 75% of the work. 25 ones, 25 threes, sorry guys, 25 ones, 25 three times. Now 4 ones, 4 twos, 2 ones, 2 hundreds. So 100 times 3 equals to 200 plus x. So x would be 300 minus 200, which is 100 men. That's it, guys. I hope you understand this. If you have an idea relation between work, time, and efficiencies, okay, you can solve this problem without writing the formula also. But I would like you to uh, get practice this formula. Let us move on to next. I had put the same problem. Okay, you pause the video and try to complete that problem. That would be the last problem of this video. Fine, guys. A contractor employs 300 men to complete the work in 16 days, but it was known that only 20% of the work is done in 4 days. So how many additional men are required to complete the work on time? Now look at here, guys. I'm not going to write formula, explain the scenarios and all. Directly I'm doing like this. 300 men worked for 4 days and they are capable of working 20%. That equals to 300 plus extra men should work for how many days? Out of 16, 4 days completed, 12 days is remaining. And how much work should be completed? Out of 100%, 20% completed, remaining is 80%. So 20 ones, 24s, 4 ones, 4 threes, 3 ones, 3 hundreds. 100 into 4 would be 400 equals to 300 plus x, whereas x equals to 400, 300 difference is 100 men. So what formula I have used? M1 D1 H1 by W1 equals to M2 D2 H2 by W2. I hope you understood work equivalence formula and LCM method. These are the two important things in time and work. I have given you the minimum number of problems where you can uh, understand the method and apply it in some other problems with the different conditions also. I hope you understand this. So I'm going to continue the time and work discussion in the second part. I'll try to complete that time and work basic to advanced problems and different conditions for different models in second video itself. Okay, let's see if this video part 3 comes or not. Like I don't know how many problems I'm going to put in that. I'll try to put the complete models in the second video itself. We'll see. Try to complete that video also so that you will get a overall idea about time and work. I hope you understand the problems, guys. So stay tuned and try to watch the remaining videos also. Thank you.